as you can see that I have this Python course folder, and there I make the outlier detection folder, and in this outlier detection folder I make this outlier detection.py. This is our Python file where I'm going to tell you about different this outlier detection algorithms and how to remove the outliers from our data sets. So as you see the files in our folder, I have only one file, which is outlier detection.py in our folder of outlier detection. So let's start with the coding session. First of all, I'm gonna import a dataset in sklearn library, which is a machine learning library. We have some datasets, already some datasets in this library, and to import that datasets, just we have to write from sklearn.datasets import load Boston. Here, if you don't know, load Boston is a housing Boston housing datasets. In Boston housing datasets, you have few points like, let me first show you the what kind of dataset it is. So here, as you can see, it is the datasets of some factors on which based on some factors, and here are 13 columns in total, and here are the price of the house in some, you can say, million or billion or lakhs, I don't know about that. But here you have some points. Here you have some these factors where you have to manage or do some operations, and this is the basically the target of those input values. Like, if you have these much if you have this much values of your house, or if you have these much values of your house, let's say every number denotes like the security around your house, the number of neighbors of your house, the acres of house, the number of bedrooms, and other factors. By calculating and combining all those factors, we get some price for our house, and it is something like based on lakhs or thousands. I really don't know, but this is the target value we have get from our data sets. So this is our data set. This is the dataset in load Boston, which is the Boston housing datasets. And to get the datasets, we just write make the object of that load Boston class. It is basically a class. So when we execute that, dataset is became our object. As you can see, dataset is a utils.bunch. In this we have this data. uh, Data is a key, and this is a key having the value, which is a dictionary. And then we have the target. These we have to just focus on these two, which are the mains, and rest of our, you can just don't care about these for right now. And we just get the data sets. Now we get our x and y. X is basically when we are making some machine learning models or deep learning models. For that, x is a training data sets. We just write the capital X, and y is the target variable, where we have to just target. That means the when we are providing our x data, when we are providing our input, then model will have to give the output as the y we have provide. Then model will have to give the output as in the y. So that's how we're gonna make some machine learning models. And for this, we just use this x and y, and make sure that in machine learning, in deep learning, in of these domains, capital X is the input and y is the target. We don't write this small x, because the small x means something else in machine learning. So don't never write small x for input datasets, for training datasets. So that's all for these datasets. We have our dataset x and y. We have our datasets, input dataset and the target dataset. Then let's get our first algorithm for outlier detection, which is isolation forest, which is present in ensemble. Pronounce it like ensemble, although it start with e, which by saying we say it is ensemble, but we pronounce it like ensemble. So from sklearn.ensemble import isolation forest. It is a class, and we import the class, then we just provide the hyperparameter 0.1. It is also a default value, and we just provide the hyperparameter. You can provide any values also and make the class object, then just predict that what are the outliers. So as you can see, it gives 111, which means it is not an outlier. One means it is not an outlier, and where it says like -1, -1, -1 means these values are the outliers. So we have to remove those. For that, we just write x new equals to x, where y hat is not equals to -1. So when we just write this, see, x has rows 506 and x new has rows 455. That means it removes the outliers, but we have to remove outliers also from the target variable. So this is the target variable. So next, this is all about the isolation forest coding part or the practical part. Now let's come on the elliptic envelope, which is in covariance, which is in scikit-learn library covariance module, having the class if elliptic envelope, and just import our class. Then we make the object of our class having contamination 0.01. As you all know, 0.01 means 1% of our data. Then we just get our y hat from this e. Just make our different objects so that we can differ it from isolation forest. So just fit and predict, and x new from e, y new from e. Let's give a new name so that we can differ out the difference in between. So as you can see, x has rows 506, x new has 455, x new e also has 455. So they both give the same. We can say that maybe those are same, or maybe those cannot be, because we just don't see the rows values. As we can just say that maybe those the output of these and this are maybe equal. So let's take the next algorithm, which is the local outlier factor, which is in scikit-learn.neighbors module, imports local outlier factor class, and we just import our class, make the object of our class. Next, we just predict the and get the y hat value, and just make a new variable so that we can see the difference in between all of these algorithms. So just execute that. Now let's see. Yeah, as you can see, it remove less number of rows. It, according to this algorithm, according to this outlier detection algorithm, local outlier factor LOF, according to this, it has 465 number of rows which are not in outlier. That means 506 minus 465, which is 51. According to this algorithm, 51 rows are an outlier, and according to this algorithm, 61 rows are outliers. So every algorithm has its own value and its own existence and its own criteria. So based on that, you can use any of the algorithm, and you may find new algorithms on internet. You just go and search through the outlier detection algorithms. New algorithms were every day came, and you just see them. But I gave you a basic intuition of that, so that if you want to remove the outliers in your dataset, then you can just perform that, and don't get panic when you just see like you have to remove the outliers. So don't get panic. You Then nothing going to be worry about. You just have to do these codes, and every job is get done for you. So after all, at last, I want to say that just keep do practicing about different data sets. Do practice on different data sets. Try to remove the outliers. Try to see those data set and that how it remove those outliers, and just try dig into more about that, what kind of rows it remove, what how this data or how this algorithm remove the outliers from the data set. So that's all for today's session. Thank you. Bye bye. Take care. Keep motivated and keep learning.